we basically have created read-write level permissions on,
Yeah.
on an atom.
And we're tracking it as it goes through this Mach 5, Mach 6.
I hope people who are watching and listening to this understand how outrageous what you just said.
You got some fluid. You put in some particles. It can be dust particles, oil particles, alumina dust. And those dust are going to track where the fluid is moving. Right?
Got it.
That's the idea. Yeah, because the fluid is just moving around on its own.
But you need to be able to visualize it somehow.
But you need to visualize it somehow. So you're going to put some tracer thingy that's going to track where the fluid is moving. Okay? But here's the problem. Those tracer particles are quite big compared to the air itself.
Okay.
Right? The air is made out of nitrogen and oxygen. These are single molecules. The particles are made out of, let's say, 10 to the 5, 10 to the 10, something like that, number of these. So there's going to be a particle lag. There's going to be, the air is going to be pushing this particle, and then the particle is going to move, and then I'm going to image it and create this velocity field. Right?
So there's a delta between the thing we're tracking and the thing we actually care about.
Yes.
Because of this scale difference.
Yes. That's not going to matter at low speeds.
Matters.
But at Mach 5, Mach 6, now all of a sudden, maybe it matters. And here's what they did. They said, okay, instead of having tracer particles, I'm going to use something called Krypton tagging velocimetry.
Krypton.
They're going to use Krypton gas.
Okay.
And Krypton atom, which is a monoatomic gas because it's a noble gas. It doesn't make molecules. That's going to be my tracer.
Because it is closer in size to the thing we are trying to trace than the other alumina dust and other
Exactly.
things.
And this is the part that was like a little bit non-trivial to me, right? It's like with dust, it's really easy to set up a 2D laser field and like image the dust. With a single Krypton atom, how are you going to do that? Here's what they did. And I thought this was very cool. So they got a laser and they used the laser to ionize Krypton. Okay? Photons interact with a single Krypton atom. It's going to bump up in energy level and ionize itself.
And then you're going to be able to track it.
And now this Krypton is an ionized thing. And when it goes back to its normal state, it's going to release a photon. The Krypton itself is going to create the photon that we're going to use to track it with. So there's like a read. So there's a write mechanism, right? We're writing the Krypton, we're tagging it.
We're tagging it,
And then we're reading it later.
when the photon's released.
Yeah.
And it's